So ADRAD, or which is short for Aggie Doppler radar, has had kind of several instances through time.
Radar at A&M goes way back. It's obvious in the construction of this building how important that was in 1973.
Since I've been here in the early 2000s, it's been about the same. So it's been an S-band, like 10 centimeter wavelength Doppler radar, really strong powered radar that we've used for education and research.
Through all of this time, there has been upgrades that have been made to it. There have been kind of maintenance things that have had to have been done. And so it's been a collaborative effort amongst people here at the university, professors, engineers, IT people, to kind of keep it going for, over 50 years. Okay, so what is radar? Simply, it is something that shoots out a beam and listens for how much of that beam comes back. And how much of that beam comes back is going to tell us what it is bouncing off of. The more rain, the more hail that is out there, the more of that energy is going to come back.
Why did the current radar need to be replaced?
ADRAD is old. That doesn't necessarily mean bad things in the radar world. A lot of things get reused because we're talking about a technology that's still very expensive.
ADRAD right now is single polarization, which means it's only transmits and receives in the horizontal. So you can imagine a snake on the ground, right? So that's the horizontal propagation that ADRAD normally works at. Dual polarization, you can transmit and receive at a different polarization, and so the new radar can also do vertical polarization, which I call the dolphin. So it's going in this frame of reference, and so it can see when it hits, raindrops and things like that. It can tell if they are big and flat or big and round. So that's a bit like that would be a big raindrop. This would be a big hail ball, and so we can't really. ADRAD can't tell that as easily as this radar.
So what will the new radar offer? Now, it may seem simple, but one of them is it will be running all of the time. Right? We have this situation where now we can be extremely weather aware, the students are, from a radar that is on the roof of their building to seeing what is happening, right? They'll be able to not miss a weather event because it was 3 a.m. and we're not here at the computer running the radar type of thing. They will have that ability.
I think it's going to be really valuable because it will be relatively local storms, and students will already be very interested in those and probably already following them from National Weather Service radars, and maybe from this very space, seeing some of the development and then being able to correlate that with some of the advanced capabilities of this radar.